From the past, the nature of light has been studied by many scientists. Some scientists believe that light had a wave nature, as others defended the particle nature of light. Isaac Newton, based on his experiments, liked the second theory, but Newton's theory was rejected later. To his theory's rejection, one of the most famous experiments is the one which performed by Thomas Young in 1801. In the second half of the 19th century, physicists studied why some materials absorb and emit electromagnetic radiation better than some other materials. In 1900, Max Planck proposed the theory of quantum energy that could justify one of the problems of physicists of that time. He explained the relationship between black body temperature and the amount of electromagnetic radiation. It was true that the photoelectric effect experiment confirmed Planck's quantum theory, but created a new problem in wave theory of light. This experiment can only be justified by considering the light as a particle. A few years later, Einstein, for explaining the photoelectric experiment, presented the concept of wave-particle duality of light. Now, consider a particle that is separated from a moving source. The motion of the particle is always affected by the movement of its source. Now, notice how the electrons move in an atom. In this situation, the electron has two kinds of motion, moving around itself and around the nucleus of the atom. When the electron is excited, it emits a photon. The motion of the photon is affected by the motion of its source, electron, and must include both types of motion of its source. In other words, since the electron is the photon generator and the electron is rotating around itself and around the nucleus, the emitted photon also has these rotating motions. So, the photon is a particle that always traverses on a helical direction and has a three-dimensional motion. In Saleh theory, since the photon has a projectile and impulsive motion, it is a particle. On the other hand, as it has a rotational motion, it behaves wave-like. Saleh theory, as Newton believes that light consists of particles with a constant mass, but furthermore, Saleh theory believes in a three-dimensional trajectory for it. In this theory, photon behavior is studied in three dimensions. Finally, we would conclude that the constituent particles of light have a spiral motion around the axis of the trajectory and rectilinear advancement trajectory. In fact, particle theory of Newton is only the rectilinear motion, and wave theory is the image of three-dimensional motion of particles in two dimensions. In other words, the motion of light particles is a three-dimensional spiral motion on the cylindrical environment, and these particles, that called photon, move on the steps of an imaginary screw and move forward. Now, the question is that how different colors of light are created. Color variety of photon. An electron that revolves. And here is a photon born with all its beauty, its speed, and its incredible brilliance. An angel. We believe that the color variety of photon is due to a change in the value of its gyro radius, and a different value of the rotational radius is due to electron motion with different distances around the nucleus in atoms. Therefore, the colorfulness is the effect of the rotation of photons with different gyro radius. As mentioned before, the photon has a three-dimensional motion, including a wave-like movement and a rotating motion. So its energy consists of these two types of movement. In Saleh theory, the energy of wave-like part is same as the energy that Max Planck has experimentally measured in the laboratory. And the rotational kinetic energy is the energy same as the energy of a rotational globe around its center. But eventually, this photon with constant mass passes the distance between 2 points by linear velocity c, so its energy is equal to a half mc squared. According to the explanation of how the photon is moving, the final formula for the energy of photon will be like this. In fact, it can be said that the photon translational kinetic energy is equal to the initial energy of the photon minus its rotational energy consumption. In this formula, the first part is the energy of a wave-like part, and the second one is translational kinetic energy, and the third part refers to the rotating energy at a constant angular velocity. H is Planck constant. Mu is frequency, where m is the photon mass. C is linear speed of photon. R is gyro radius. And omega is angular velocity. The important and interesting point in this view formula for the energy of photon is that the variables of this equation are homogeneous. As you know, for a wave with constant velocity, the frequency is directly related to the inverse value of wavelengths. Therefore, the variations of both variables, the rotational radius and the frequency, are same kind of the length. However, in the equality of h nu equal mc squared, the variables are frequency and mass, that these variables are completely heterogeneous.